Oh, so this is the video presentation, take two, for the project. And the first thing I want to talk about is the bubble sort and the bubble sort flowchart specifically. Okay, and so the first thing I want to talk about is that it starts and it goes to the loop over the array, and typically they compare between a integer I and a of integer I incremented by 1. And if a of integer I is greater than a of integer I plus 1 incremented, then they swap and they repeat their inner loop and outer loop until swaps until they end. And that's how the bubble sort flowchart works. The selection sort flowchart starts, and it's from loop I from 0 to end incremented by 1, and they find the minimum index from integer I to n, and they swap the minimum from a of integer I, and again they repeat until it ends. And the merge sort flowchart works similarly. It's a start, and if array size is greater than 1, then they split into left or right, and recursively they call the merge sort on both halves, and merge sorted halves, it eventually ends that way. And as we can see in the execution for the time example, for the chart that was produced here, we can see that the merge sort was actually significantly faster than the bubble sort and the selection sort, by a couple fractions of a second, but regardless it was faster. When for those 1,000 random numbers, again merge sort is, like I said, almost complete instantly, while the other two took significantly more time. Now the next thing I want to talk about are class members and operator overloading in the bushel class. So I'll talk about the terms and what they mean. So like the class members are like the variables and functions defined inside a class, and the greater term, it'll return true if both apples and oranges are greater, and the equal term checks if apples and oranges are equal in both bushels. The lesser term returns true if both are less. The operator term, on the other hand, replaces the equal term and allows A to not be B. And the operator of less than and greater than are just comparisons between less than and greater than operators. The operator overloading, it lets us use intuitive syntax when comparing complex objects, like in our bushel class. The next thing I want to talk about is the RSV, with the encryption and decryption. So the thing I want to talk about is that decryption. It marks the zigzag pattern with asterisks. It fills in letters row by row. It reads in zigzag. It's a decrypted message. And so, like for example, the message could be Christmas is a holly event, and then with it being decrypted, it splits into 3 different rows, 3 different rails, and it'll like divide the letters up in between each row to make it basically going downward, upward, downward, upward, and it'll make it just gibberish essentially. It won't make sense of a word. Like for example, it being encrypted could be CAEHLNTHRSSH, so on and so forth, but decrypted it would be with no spaces, of course. Christmas is a holly event. And then for the binary tree, I did have a sketch on here, although it might take a little time to find. It was somewhere deep in here. Should have organized this a little better. Oh. So in that basically what I wanted to talk about that was the LMR and the RML. And the LMR is the here it is the traversal ascending order. So it would be traverse left, then print node, then traverse right. So the output would be Biden, Carmon, Donald, John, Jonathan, Luke, Mark, so on and so forth. And then for the RML, the traverse, it's descending. So it would be traverse right, print node, traverse left. So the output would be, in case of these names, it would, or in case of these children, people, kids, whatever it may be, it'd be Paul, Newman, Nora, Samantha, Sama, Sam, Mazen, Matthew, Mark, Luke, and so on and so forth. These traversals allow us to view the BST in sorted or reversed order without like reorganizing the structure at all. So we don't need to do all that. And yeah, I think I'm significantly over my time, so I apologize for that. But I hope this is what you were looking for in the video. Uh, and thank you so much for your time. And yeah, thank you. I appreciate you so much, and thanks for this great opportunity. Thank you.